In this video, I wanted to go over an alternative host software example that interfaces with serial command sketch on the Arduino, which I've prepared in MATLAB. So I basically have made a MATLAB version of the Python class and the Python GUI. Made MATLAB versions of each of those two things, and I want to just give you a brief demo of them in this video, and to just kind of walk through the code just to show you how it works, in case you prefer to work in MATLAB, or it's easier for you to work in MATLAB than it is to maybe in Python. So there is a caveat with this, and that is that some of the MATLAB stuff is specific to the Windows platform. So if you are using MATLAB on Linux or Mac OS, this code will probably not work without a bit of modification, which I actually wouldn't know how to do off the top of my head. Here I have the same hardware setup as we've had before. We've got the three LEDs, green, yellow, and red, connected to some digital outputs. We've got the two tactile switches, and then we've got the potentiometer, and the sketch, the serial command sketch, has the two LEDs that are flashing here at 1 Hertz, set up so that we can change the duty cycle of the green LED, and we can change the blinking, or the period of the blinking, for the yellow LED, thereby adjusting its frequency. So here I have my MATLAB window, and I've got the editor up, and I've got two MATLAB files open, two M files open. One is the serial command.m, and this gives us an object-oriented class that will allow us to interact with the Arduino in the same way that the Python class allowed us to interact with the sketch on the Arduino. So you may not have ever seen object-oriented MATLAB before. It actually is not terribly different from Python in terms of writing object-oriented code. There are a few differences, but one is that you have to put the class properties up here, and then you have the class methods. You might be familiar with that from Java or C++. But we're going to have two properties for a serial command object. One is called dev, which is the actual serial device. That gives us a software object through which we can actually send and receive on a serial port. And port, which is the port name for the Arduino. In the case of a Windows platform, it'll be something like COM7 or COM9 or something like that. In the case of a Linux platform, it might be more like /dev/ttyacm or something like that. There'll be some sort of file name looking thing for the port. And then we have some methods. And this method, the first method, is basically the object creator. And it takes one argument, 0 or 1 arguments. And in MATLAB, you can do that through this var argin structure, and nargin gives you the number of arguments. And so if you don't pass it an argument, I've got it set up so that it tries to identify the list of available COM ports on the computer, and then it attempts to match one of those available COM ports with known Arduino Uno Rev3 vendor ID and product ID combinations. And so this is a cell array of vendor ID and product ID combinations, and I formatted each of these strings or embedded them in strings that are formatted so that they look like they would appear in a registry query. And so this is where the Windows-specific stuff comes in, the way that we're actually getting a list of potential Arduino vendor ID and product IDs, or devices with vendor IDs and product IDs, is by doing a registry query. And so we set up this key, and then we execute basically a DOS command, and then we parse it a little bit, and then we go loop through it and see if we can find one of these devices that's returned that contains one of these vendor ID, product ID combinations in this cell array here, and then extract the COM port number from between parentheses in the following line, which will have the so-called friendly name of the device. And so we see if our the Arduino matches one of the ports, and then we basically try to open a serial port using that port that we've identified. If we do want to, we can, if we know what the port name is for the Arduino that we'd like to connect to, we can just pass that in to the creator as a string. So if it were COM7, we could invoke the serial command creator method with that string quote COM7 quote, and it would basically just try to use that one. So it opens up the serial port with a baud rate of 115,200 bauds. It configures the terminators of the serial port so that the receive terminator is carriage return and line feed both, and the transmit terminator is carriage return. And the reason for that, normally in MATLAB they are specified to be the same thing by default, and I think the default one, if you don't specify it, works out to be just a line feed character. This matches the way I set up the sketch, and there was a reason for that which I didn't actually go over. But if you connect a serial port up to a terminal device, like a serial terminal device on Linux, this might be an Xterm. In Windows, it might be something more like a program like PuTTY, which is a very popular, freely available serial terminal emulation program that you can point at a COM port. It basically gives you a window where you can type stuff in the keyboard, and whatever is sent back from the serial device on the other end appears in the window. When you are in that environment, it's very natural to use the enter key to signify the end of the line, and the enter key is basically generates a carriage return. And if you wanted to send a new line character, you would have to type another control key, like I think Control J or something like that, or you have to have a setting where if you hit enter, it substitutes both the line feed and a carriage return or something like that at the terminal emulation level. And on the other end, if you have a terminal like that, normally what the carriage return character will do, the effect that will have on the cursor position, is to move the cursor back to the first column in the line that you're currently working in without advancing to the next line. And the effect of a new line character is just to advance you to the next line without moving the column the cursor is located at back to the first column. It's only the combination of a carriage return and a line feed that gives you both advancing to the next line and going back to the first column. And so it's actually kind of annoying if you don't have both characters to terminate a line when you're dealing with a serial terminal, because you'd like to see this stuff and it winds up in really weird places on the screen, either sort of typing over stuff that was sent in the last transmit, from the embedded device, or you wind up with this kind of cascading waterfall thing where it's always moving to the cursor's always moving to the right, and it kind of falls down to the next level. And so this is my preference. You obviously can structure your sketch to do whatever you like, but whatever you do, you have to make it match the line terminators in the software. Otherwise, you won't see anything happening. So that's just something to be aware of. It took me a little while to figure out how to do this in MATLAB properly so that it talked to the sketch. Once I did, it works pretty seamlessly. So then my other methods match the methods in the Python class. So we have a get green, and we have a set green, a get yellow, get red, set red, get switch 1, get switch 2, and get pot. And that's it. So what we do is we effectively write out a line, which is just the command, and write line will automatically append the appropriate line termination, in this case the carriage return, so we do not need to explicitly put a carriage return here. We just pass it the string, and the write line function will automatically append for us that carriage return. And then in this case there's a return value, and so we're reading a line from the serial port, and we're using a hex to decimal function, which is built into MATLAB, that will take that hex string and convert it into a numerical value, which we will then return. And for something that doesn't have a return value, like this command, green bang, we're using string concatenation, which you can do by making a vector, and you just put the first part of the string, comma, and then the second part of the string, and we're basically taking the value that we pass in and converting it into a decimal value, or we're taking the decimal value and we're converting it into a hex string, and then we're concatenating it here. And then obviously the write line will also append for us, like I said, the carriage return. So that's how all of these things work, and we can basically make one of these objects out here. So we could say foo equals serial command, and it basically found COM7, and we now have an object called foo in the workspace, and we can invoke a method on foo by using this dot notation. So we can say foo dot get red, and we get back 0 because the red LED is off. We can say foo dot set red 1, and that has the effect of turning the red LED on. And then we can do the get red method again. We get back a 1. We can say foo dot get switch 1, and without pushing the switch, get back a 0. We hold the switch down and repeat this. We get a 1. If we let it go, we get back a 0. Same thing with switch 2. So if we get switch 2 without pressing it, get a 0. If we press it, hold it down, we get a 1. If we let it go, we get back a 0. And we can do get the potentiometer value. So right now it's about halfway, so we should get something like 500 or so. 503. If we turn it all the way over to, say, the ground side, we should get back 0. Turn it all the way over to the +5 side, we should get back 1023, which we do. It's all very comforting. So it works the same way. We can change the, we can do the, let's see, foo dot set green, and let's do 100. That'll give us a duty cycle of 10%. So You can see the green LED is flashing with a very brief on time and a longer off time. You can do foo set yellow to, let's say, 1,000. That will give us a 2-second on-off period. So that's, you can of course issue these commands from the MATLAB command prompt, as I've been doing here, or you could actually just put these into a MATLAB script and put it inside a loop and execute things in sequence iteratively. So it all works just like the Python would. The GUI, I have it set up here a little bit differently than I would have in Python, or than I had it in Python. So since you have to run the GUI from within the MATLAB environment, I have it set up so you have to pass to the serial command GUI the serial device, rather than having it attempt to open up a serial device. So you have to first create your serial object, in this case foo, and then we have to invoke the serial command GUI with an argument that we pass foo here. And so GUI is over here, and I have it set up so that it's the same basic structure as the Python GUI. So we've got a toggle red button, which we can click and toggle the red LED on and off. There's some labels that we can interact with by pushing the switches on the physical setup. You can see the switch's status changes from 0 to 1 and back to 0. And then we can adjust the pot. This is going over the +5 side, and you can adjust it back to the 0 side, and that all works quite nicely. Got some sliders. I don't particularly care for the way that the MATLAB GUIs render the sliders, but we can make the duty cycle of the green LED longer by moving the slider over to the right, making it shorter by moving it over to the left. You can move the yellow LED slider back to the center. You can make it blink very fast. And there you have it. So the MATLAB GUI code is not necessarily super interesting, and there are different ways of setting up a MATLAB GUI. There's actually an application developer that allows you to make a GUI, construct a GUI within sort of a GUI, but I just threw this together by writing the script out. But effectively what we're doing is we're passing in the object, the serial port object or the serial command object, and then we're getting the name of the variable that's passed in with the input name function. And then we're looking for a window that already exists that has a name or has a tag that is basically whatever that device name is, _GUI _fig, and if that does exist, so the GUI is already running, we basically just want to raise it to the top level and then return. We don't want to create a new version of the same thing that's talking to the same serial object. If we don't have one of these windows running, then what we do is I have it create the figure window and give it a title and change some of the properties here, and then hook up the delete action on the window to a callback function, which basically stops the timer object that is periodically running every 50 milliseconds to update the labels. Then we create the red button, and there's a callback here for the red button when it's clicked, and that basically just invokes the setRed method, again with the 1 minus the getRed method. return value. That is the effect of toggling. And we have the sliders, and there's a callback function for the slider, for the green slider, and then here's the yellow slider. And then these are the text, the labels basically. They're called text objects or controls. And then this is the timer, which does the update. The timer works a little bit differently in the MATLAB GUI system than it does in tkinter and some other GUIs. So the way that the GUI in Python was set up was there was an after method which created a one-time callback, and then that callback function would create the next one. So the way that it appears to have to work in MATLAB, although it's supposed to be by default you get the timer only executing one time. The only way that I could actually get this to work, at least without beating my head against it for a lot longer, was to actually make it a periodic timer. And so, we have a period that's set here at 0.05 seconds, and then the actual function that's called when the timer goes off is this function here, the update status function, and it basically just changes the string property of these text objects with the appropriate return values from the dev.getSwitch1, dev.getSwitch2, and dev.getPort. And then this is the function that basically attempts to stop the GUI stop the timer when the GUI is shut down. So if I shut this down, we occasionally will get this error message, but that doesn't happen every time. So if I restart the GUI, and I shut it down again, I don't get that. So I'm not quite sure how to squash that. My intention with this callback function on the window destroy was to squash error messages like that. But my guess is that effectively sometimes the callback function for the timer is actually running when you are actually destroying the window, and so by the time you get to one of these things to update, let's say the third string thing, it's no longer in existence and you get this error. So that doesn't happen every time, but it does happen occasionally. It's not that big a deal. I'm not sure it would be a good thing in production code, but we're not doing that right now. So that's it for this. Hope it was useful. Certainly the GUI part is just something that's nice to interact with, or show you how to interact with the Arduino sketch. For demo purposes, obviously you don't need to write a GUI for Mini Project 2. You may be just writing some kind of Python script or MATLAB script that has no GUI thing, but it basically just issues commands through the serial interface to your embedded system and gets information back and stuffs it in a file or stuffs it in a vector or matrix in MATLAB, and then you do the visualization after the fact. So anyway, that's it for now. Thanks for watching, and let me know if you have any questions.